In this video, an artificial agent learns to fire a cannon, adjusting its shooting angle through trial and error until it finally hits. But what makes this video unique is that you don't just see the shots. You also see inside the agent's mind. Through animations, you can follow both the actual cannon shots and how the agent's internal memory evolves over time, showing how it learns which angles work best. The cannon shooting problem is about finding the perfect firing angle to hit a target at a fixed distance. The agent selects an angle, fires the cannon, and observes where the projectile lands. The goal is simple: get as close to the target as possible. To guide the learning, we use a reward signal. The closer the shot lands to the target, the higher the reward. In fact, the reward is defined as the negative distance between where the projectile lands and the target, so smaller errors give higher rewards.
So far, in earlier problems, we have assumed that actions are discrete, chosen from a fixed set. But in many real-world problems, actions are continuous, meaning the agent can choose any value within a range. So how do we handle that? A common approach is to sample actions from a normal distribution, defined by a mean and a standard deviation. The mean represents the preferred action, while the standard deviation controls exploration, how much we should deviate from the mean. In the cannon problem, there is only one state. Therefore, there are only two memory parameters, one for mean and one for standard deviation. Then, as the agent trains, it gathers experience, and that experience updates the memory parameters over time.
The frame on the left represents the environment. This frame also displays information such as the shooting distance. The target distance is 800 meters. The frame on the right shows the agent's memory. The policy is given by parameters m and d, describing the normal distribution used for sampling actions. The value return minus base together with grad log determines the change of m and d. The shooting now begins. There is a small explosion if the cannonball misses the target, and a larger explosion if there is a hit. The animation is now paused to reflect. During the first episodes, there were some hits and some misses. The agent has already realized that the shooting angle should be around 33 degrees. The exploration is still high due to a relatively large deviation, denoted d, and here set as 5. A large deviation results in a wider spread of sampled angles. Another observation is that the baseline, which reflects a typical reward, is far from 0 and requires further tuning. Now we speed up the animation to fast-forward evolution. As you can see, the agent memory is further updated. A trained agent is now in place. Success! This is fantastic. In these final episodes, we can observe the desired behavior. The target is consistently hit.
One can note that the deviation is now smaller than before, indicating reduced exploration. The agent feels confident that it has found a good angle.
The problem presented here is one of many example problems described in the book Reinforcement Learning Explained. This was only a brief description. Many more details are presented in the book. Please visit the book's homepage for more information.